perfectly machined metal part? It doesn't happen by magic. It follows a powerful digital workflow called CAD CAM CNC. Understanding this process reveals how modern manufacturing creates everything from car engines and aircraft components to medical implants and smartphone parts with incredible precision. Many people watch a CNC machine cutting metal and assume the machine does all the thinking. In reality, every flawless cut begins long before the spindle starts spinning. Behind every precision machined component is a carefully planned digital workflow that ensures accuracy, efficiency, and repeatability. If you've ever been confused by terms like CAD, CAM, and CNC, don't worry. By the end of this video, you'll understand how these three technologies work together to transform an idea into a real, high-quality product. Step 1. CAD, Computer-Aided Design. The journey starts with CAD, where engineers or designers create a detailed 2D drawing or a 3D model of the part. Every feature, including holes, pockets, slots, chamfers, fillets, threads, and dimensions, is carefully designed according to engineering requirements. Designers also define tolerances, surface finish requirements, material specifications, and assembly features. Modern CAD software allows engineers to detect design errors before manufacturing begins, saving both time and money. Popular CAD software includes SolidWorks, AutoCAD, Autodesk Inventor, CATIA, Siemens NX, and Fusion 360. Step 2. CAM, Computer-Aided Manufacturing. Once the design is complete, it is imported into CAM software. This is where the machining process is planned. The programmer selects the raw material, work holding method, cutting tools, spindle speeds, feed rates, depth of cut, coolant strategy, and machining operations such as facing, drilling, pocket milling, contour milling, tapping, boring, and finishing. CAM software then calculates the safest and most efficient tool paths while avoiding collisions. Before sending the program to the machine, the entire machining process is simulated in 3D to verify that everything works correctly. Finally, the CAM software converts the tool paths into G-code and M-code, the programming language understood by CNC machines. Step 3. CNC, Computer Numerical Control. The generated program is transferred to the CNC machine. The operator installs the correct cutting tools, secures the workpiece, sets the work offset, measures tool lengths, and performs machine referencing or homing. After a dry run or simulation, machining begins. The CNC controller reads each line of G-code, controlling spindle rotation, feed movements, coolant, tool changes, and axis motion with micron-level precision. The machine removes material layer by layer until the finished component matches the original CAD model. Quality inspection. After machining, the part is inspected using measuring instruments such as vernier calipers, micrometers, bore gauges, height gauges, dial indicators, and coordinate measuring machines, CMMs. Critical dimensions, tolerances, surface finish, and geometric accuracy are verified before the part is approved for production or assembly. Hash why this workflow is important. The CAD CAM CNC workflow provides several major advantages: high accuracy and repeatability, faster production with minimal human error, reduced material waste, optimized machining time, better tool life through efficient cutting strategies, easy modification of designs without starting from scratch, consistent quality for mass production. This digital workflow has become the backbone of modern manufacturing across the automotive, aerospace, medical, defense, electronics, and mold-making industries. Story flow and emotion. Imagine designing a simple metal bracket on your computer in the morning. Within minutes, the CAD model is complete. CAM software instantly calculates the best machining strategy, selects the proper cutting tools, and generates optimized tool paths. A short time later, the CNC machine transforms a solid block of metal into the exact component you imagined. Watching an idea evolve from a digital sketch into a precision-engineered product is one of the most satisfying experiences in manufacturing. Every movement of the cutting tool represents the perfect combination of engineering knowledge, programming, and advanced automation. Hashed conclusion. The complete manufacturing journey is simple. Idea, CAD design, CAM programming, G-code generation, CNC machining, quality inspection, finished product. Each stage plays a vital role. Without CAD, there is no design. Without CAM, there is no machining strategy. And without CNC, there is no precise manufacturing. Together, they form the foundation of modern precision engineering. CTA. Now you know the complete workflow. from CAD to CAM to CNC. Which stage fascinates you the most? Designing in CAD, programming in CAM, or watching the